Well, hi everyone, and welcome again to our library's virtual event series. And we are ready for the summer. We have with us today Warren Hart, CTC's astronomer, and he's going to be doing a night sky tour with us for the month of June. So we're going to go ahead and get started. Before we get started, our virtual events, we put in the comments section various links to different things. And one of them is for our programs. So if you ever want to register for one of our events, that's a really great thing to do because our library, when we give out our scholarships, we check to see who has attended one of our library events. So make sure you check out all of the links that we put in. Today we have Warren Hart, and I'm going to go ahead and let you take it away.
Okay, thank you, Cindy. Well, welcome everyone. Glad you're here with us again. And we're going to be talking about what's going to be coming up in the month of June, which is right now, of course. And so what we'll do is Cindy will post for us the first page of our calendar and let you look at that. You can also get on there and download the calendar. It's a 2-page because
All
of
right.
the size of it. And if you'll scroll up on it to the first page part, there you go. All right, here we are on Wednesday, and you notice it's already, we've had an event. This morning was the third or last quarter of the moon. And because of that, we can know that when we would want to look at the moon, it will be in the morning because it has just gone past in the previous month in May, it has gone past the full moon. Full moons are always at midnight to 1 o'clock. And so the moon is continuing in its orbit, and it's now in the early morning hours. And when you go out tomorrow morning to get the newspaper or whatever you do early before sunrise or just after sunrise, if you look to the west, you will see there the moon as it's proceeding on, trailing, if you will, the sun or ahead of it and going down there. So a third quarter moon. Now, we're going to have, if you see also on here, if you look down next Monday on the 7th, you're going to have something that's called an apogee of the moon. The moon, as it goes around our Earth, it's a full circle, but it's not a perfect circle with a constant radius. It would be in either, some people call it an egg shape, but I just remember it as being like an elliptical orbit. So there are two separate points on the orbit of the moon as it goes around Earth. One time, and this is one of those times, is when it is the farthest away from us and distance. And as you can see there on the 7th, it is of all of the apogee moon periods this year, there's 13, because August will have two of them, because August also is a month with 31 days, and we can have two events in 1 month. And it is the farthest away for this orbit, and there's your distance, if you will. And the other thing, let me ask you as a question, and you can call it in, and Lee will get the answer from you. on the size of the moon, will it be larger or smaller than normal because it is the farthest away, and it's called an apogee. That means far away. All right, while we're doing that, let's look at the next day,
Hey,
which is
um,
the 8th. Pardon?
Warren, before we go move on to that, can I show everyone that they can look at the links and follow
Sure,
along on their own?
sure,
Let's
go ahead.
We're gonna just show you really quick. There is a link in the comments for the astronomy in Mayborn Science Theater, which of course has the shows and information. But we are following along. There is our night sky calendars that you can follow along with, and we're going to go through the maps which are on this page. So, we did put that link in. So, all right. So I am
Okay, good.
ready with your very first one. Was that the first
Okay,
one?
yeah,
Yes.
the
Okay.
first one, the sun is currently in the constellation of Taurus the Bull. And if you look on there and what we're talking about, you can see that blue line going across the upper part of that white area. And the white area is the region in the sky that the astronomers chose back in 1920, 1930 for where all of the boundaries of each constellation would be referred to. Up until that time, there were no boundaries, so the size of a constellation was subjective based on who was talking about it. It could be smaller, could be larger. And so they decided that they needed, in a sense, like we do here on the ground, they needed to survey and establish boundaries for the constellation. So every constellation has a boundary, and you're going to see those as we go through here. This is Taurus, and so what we would have, and if you'll see almost right in the middle of the line there in Taurus, that's where the sun would be if we were plotting it on that ecliptic path there, and that's called the ecliptic of the sun. And that is the region of the sky, the path of the sky, where there's the only place you would be looking for either a total solar eclipse or what's called an annular solar eclipse or a partial solar eclipse. So that's where you're going to look. You're not going to look up at the North Pole. You're not going to look down and at the South Pole. You would be looking along and following along on this line here. So that's where that is. Now our next page, what we would want to look at is going to be what I was talking about. There's the calendar, and there's the moon I just mentioned. And then down on the 7th, next Monday, is the apogee that we talked about. Our next constellation, and actually the first one for June this month, and that is, if you look there, it is Scorpius. Now we can scroll up. There you go. Thank you, Cindy. Make sure, if you will, that when you refer to it, you go by its correct name, Scorpius. Now, unfortunately, there will be some that you can read at places it's called Scorpio, but that is incorrect because that is based on a faith-based belief system. That is not science at all. This is Scorpius, and this is the science, astronomy, and that's what it's called. Now, on the maps each time, you'll notice that the little black circle dots that they have different, some are larger and some are smaller. Well, right in the very middle of the page there, and it's labeled as number 9, is the largest dot right there, the black dot, and that happens to be the star that's called Antares, Antares, and that means that it is the rival of Mars. Now, what color is the planet Mars that we normally see it in the sky at night? What color is Mars? And then, if this Antares is the rival of Mars, what color would you think that Antares would be? Now, when you get some ideas, you can call that in, and Lee will tell us what some of the answers are. However, Scorpius is going to be the predominant constellation for the summer sky. And number 9 there, Antares, is significant because it will be the largest star, other than our sun, of course, but the largest star you will see with your naked eye. Now, when I say naked eye, I mean that you are not looking and using binoculars or looking through or using a telescope. It's just you out there and with your eyes. And this star, Antares, is approximately, let's see, it's about what they said, somewhere around 430 times larger than our sun. To give you a concept of that, if Antares was our sun and the center of Antares was at the center of where our sun is, unfortunately, we would still be inside that star. It is so large that the edge, if you want to call that, of the star would go out beyond us from the sun, past Mercury, past Venus, here, past Earth, keep going past Mars, keep going through the asteroid belt, keep going, and you'll get out to Jupiter, keep going, and you'll get out in between Jupiter and Saturn. It's a big star. But just in relation to it, that is not the largest star that's visible in the night sky. There's others that make Antares look like a little pinhead compared to them, but you have to use telescopes to find them. But this is the largest star you will see with your naked eye, unless something else happens throughout your lifetime. And it's the predominant thing for the summer. And notice also Scorpius, if you follow the green lines on there, it's one of the few constellations that symbolizes and looks like what it's being called, like a scorpion. So you can see the claws up there of the scorpion, and then the Antares we could say would be the heart of the scorpion, and then the body, and then the tail comes, and you notice the tail comes up, and we connect the lines to the stars, and there's 2 stars, 15 and 16. That's Shala and Lisith. Doesn't matter on the names, but that's the stinger of the scorpion. And hopefully none of you have ever been bitten or stung, I would say, by a scorpion, because that is not pleasurable at all. So that's Antares. And also, Antares, when you find it, it's easy to find in the sky. It's going to rise tonight at approximately 8:20 this evening, and you can look to the east, and it will begin slowly rising up. The claws are already up, and if you just picture on your mind there on that page we're looking at, that the horizon starts over on the right-hand side, and then as the time goes along, it starts sweeping slowly from right to left because we're looking to the south. And that's what it's doing as far as it's rising up there. And also, it is Antares. When you find it, it's 550 light years away. Now, we use that, and when I say a light year, that's a measurement of distance. It's just the same thing as saying a kilometer or an inch or a yard or a mile or whatever. We use, because they're so far away, we use a light years. And what that is meaning is how far does light travel at the speed of light, of course, in space for one full year, and that comes out approximately about 6 trillion miles and about 10 trillion kilometers. But you would multiply that then by 550, and you get a number that you may not be able to get on your page. So here's what happens. You go out tonight and you finally see Antares rising in the sky, and the photons that were uh, generated and were sent out by the solar wind of Antares, that star, out into space have been traveling for 550 years. If you calculate, pardon me, calculate back, that would be they left Antares approximately in 1471. That's about 20 years before Columbus even left Europe to sail, come over here. So it's been traveling all that time, all those photons, and eventually, when you're standing there and you look up in the sky and you see Antares, those specific photons come into your eye, to the back of your eye, are registered on the rods on the back of your eye, and your nervous system, central nervous system, takes that uh, electrical charge, if you will, brings it around to your brain, and you see Antares. And a person standing right next to you is going to see Antares, but there are different photons that they're going to see. Everyone looks at it through separate photons on there. But anyway, that's Antares, the brightest star of our constellations for the month of June, and also the largest star that you will see in your lifetime, both day and night, other than our sun. Let's go on and let's see in the calendar what is next. And we have, and after the Scorpion, you see, we've had the third quarter up there on today, and now it's going on around, and we have now a new moon. And on a new moon, we're not going to see it because it's going to be between us and the sun. And the only way we would be able to see the moon, we would be looking at we'll say, the back side of it. It's going to be the dark side of the moon. And it's hard to see something that's dark in the sky, of course. And also, the only way and the only time we would ever see a new moon is when there is a solar eclipse. There will be one coming across our area right here at the planetarium and all in a little over 3.5 years on Monday, April the 4th of 2024. in the afternoon around 1 o'clock, 1:30, and we will have our first total solar eclipse in over 500 years for here. So make sure you pray for clear skies because there's no do-over on this. It'd be another few hundred years before we'd get another one here. Anyway, that's the new moon. The next thing, just for some interest, on Friday the 11th is the earliest sunrise of the year at 6:16 in the morning. And then on the 12th is a thing called the equation of time. We're trying to put together that on our watch, but now most of us don't wear watches. We use our telephone with the time on it, and it's using the time of what we call an average sun. It's actually, they call a mean, MEAN, an average sun, so that it's a constant 24 hours throughout the year. Again, as Earth goes around the sun, we're doing the same thing like the moon goes around us. It's a circle, but we're also in an elliptical path around the sun. So a certain time of the year, we are closer and the closest we get to our sun. And there's a time of the year when we are the farthest time point from the sun. Now, the sun has a greater sense of pull of gravity than the Earth does over the moon. So there's a time when we get the closer to the sun, gravity of the sun pulls us and makes us go faster. So there's a certain few times of the calendar year that we would go faster, if you will, in one rotation of our Earth in less than 24 hours. Well, everybody would have to readjust their watches and their phone numbers at all. And then we begin to, as we leave the sun gravity so much, it begins to slow down and everybody would have to recalculate and change. In other words, throughout the year, everybody, every day, would have to reset their watch. Well, that we don't want to do that. So that's why the astronomers, we took what's the average time or whatever, and we made it's 24 hours, and that's what we use. Now, whether we are ahead of the real time of the day or whatever in relation to the sun and to that, that's what this equation is. And that is noticeable if you ever used a sundial and you make a correction on the sundial to give you your time. Let's look at the second page. Our second page here now, we're going to be, you see, our next constellation coming up is on Wednesday, and it's, well, that's an odd name, Ophiuchus, and it's called the Serpent Wrestler. And it's also, you see that I have labeled there, it is called an ecliptical and an equatorial constellation. And I've put at the below each one of the constellations a little statement that the date on here, the one like on the 16th and the same back up on the 8th for the Scorpion, is the best time is you view it that evening. So the evening of the 16th after sunset, and you would then begin, it was the best night of the year, all night or however long you want, till sunrise the next morning on the 17th to view Ophiuchus. And we do have a map of Ophiuchus. So let's see if, Cindy, okay, very good. If you'll scroll it, good. Now, you see Ophiuchus here, and look on the right-hand side of the chart, and you see the name there in the darker area called Serpens Caput. For those of you that were with us when we talked about May, that was when we talked about that constellation, or actually one half of a constellation. And Serpens Caput is Latin for head of the serpent. Well, here is Ophiuchus, and so that part of him, his left arm, is wrestling and holding on to, if you will, to the head of the serpent. And we're going to get later this month, and you see on the left-hand side, there the dashed line, you see there is Serpens Cauda, C-A-U-D-A, and that is the tail of the serpent. Serpens is a unique constellation. It is the only constellation in the sky that is divided into two separate areas in the sky. How many constellations in the sky? 88. How many separate areas in the sky? 89. So that's a good trivia question if you're wanting to uh, spring on a person and ask them how many constellations, and they tell you, and that's the correct answer, and you say, well, how many areas in the sky then are devoted to the constellations? They'll more than likely say 88, and you can say, no, 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 it's 89. And then you get to show your wisdom and your knowledge of the night sky, and you tell them it's 89. Anyway, here's Ophiuchus. He's easy to find. And if you'll notice down below Ophiuchus, you see there the constellation written in the dark, Scorpius. Well, the reason we talked about Scorpius first is because he is earlier in time that we would find him in the sky. And so Ophiuchus would be rising later after the scorpion is also rising up there. And here he is. He is, and if you can see just above him is the name of another constellation, Hercules, that we're going to be talking about. And it's easy to see and to follow along with this in the sky. And that's what I do in the planetarium, what I did last Saturday, and pointing out the path of how to find each of the constellations using the laser, my laser there in the planetarium. And I do that the last Saturday of each month at 5 o'clock in the planetarium. And so we are scheduled, and Cindy will talk about that. Also, we'll do our next virtual WebEx here just prior to the time in June. And June will be Saturday the 26th, last Saturday of the month. Okay, let's go on to the next, there you go, to the calendar. And we have gone through already from a third quarter to a new moon. The moon is still going, and on Thursday, the 17th, it's up to a first quarter moon. You remember me telling you that for the beginning of the month, a third quarter moon, you would see it when? In the morning or in the evening? Well, if you go out to get the newspaper, which time is that normally? In the morning, yes. Well, now because the moon has gone past its new moon point, and that is, remember I talked about the solar eclipse going to be at noon to 1 o'clock in April. And that's the same, that's the approximate time also for new moons. It will be around noontime when we have a new moon. So it's now gone past new moon. So when would you see a first quarter moon? Will you see it in the morning or will you see it in the evening? It's when you're driving home and you get home just after sunset or whatever, and you go outside, and there is your first quarter moon. So you will always see the first quarter in the evening and the third quarter in the morning. Our next thing is on Friday the 18th, we have two constellations. The first one there, and Cindy, let's go and take a look at Hercules the hero. There he is. Now, if you'll scroll, and you notice down below, there is written, there is Ophiuchus. And if you'll see also on the right-hand side in the dark area, there's Serpens caput, the head of the serpent. And if you'll scroll down just a little bit, the map there, a little bit more, the other way. Keep going, just a little more for there. And if you'll notice at the very top, there is Draco the Dragon. And that's going to be our last constellation we will see this month. And we'll talk about that in just a little bit. But let's scroll back up and get Hercules on there. Now, notice how we connect the stars, connect the dots, and you see his head and the club he's holding up over his head, and he's with the other arm, he's pointing down. He's getting ready to take a swipe at that serpent also, I guess. But anyway, you see the four stars, and then there's a little yellow circle with a diamond crosshairs in it, and that's A. And if you go to the second page of the of Hercules, there's information. There you go. And there's the listing of all the stars. And if you look down below the stars, you see down there the next one that says asterisms, Asterisms, right there. There's the butterfly. And then there's also something called the keystone. Let's go back up now to the first page. What is a keystone? Somebody let us know what a keystone is. And that is what these four stars will outline for us, what a keystone looks like. And there's Hercules for us in the sky. And he is easy to find because if you look to the left of Hercules, you see a large black dot, and that is in the constellation of Lyra, and that's the bright star of Vega. And your eye will be drawn to Vega, and in between it and over to the right is Corona Borealis. Corona in Latin is crown, and Borealis in Latin means north. So it's the northern crown. And there is a southern crown, Corona Australis. But anyway, you can follow across, and I pointed out in the planetarium, you go from a bright star over to Corona Borealis. There is a little bright star, not very, for Corona Borealis, and halfway between Corona Borealis and Lyra, right there is Hercules, and right in between is the keystone. Has anybody described yet what a keystone is? Well, I don't know if you've ever seen or if you have ever made an archway using bricks. You would take regular bricks, regular stones that are parallel on both sides, and you would put them there. Now, when you get to the top of the arch, you're going to put in the last point, the key stone. But for it to fit, it cannot be a straight stone again. It has to be shaved off toward the bottom and be tapered down so it will fit in between the last two on each side, and that will lock in your key, your arch, and it won't fall down on you when you walk underneath it. And that's why it's called a key stone. And that is an asterism. An asterism, all that means is it's the name of something in the sky. And here we have, in the sky, we have what we call the keystone of Hercules. Well, that is not the name of any of the 88 constellations. And so it's an object in the sky, but it's not the name. I'll give you a couple more examples of asterisms. You look to the north in the sky and you see the Big Dipper. That's an asterism. You look at also in the wintertime, you look at the constellation Orion and you see the three stars in a row in his middle of his body. That is called the belt of Orion. And that's also an asterism. And that's all that means. Okay? All right, that is Hercules. And the significant thing about that is the keystone. Also that same day, and go ahead, Cindy, we have Ara, the altar that is there. And you notice on the page, look at the very top of the dark area, and you see on the side there it says Scorpius. That's what we just looked at. And so this is easy to find. And you look in the center at the top and surrounding, if you will, my little north arrow part, and you see a dark, large star circle there just at the southwest corner, bottom left corner, and the other two up the top. That's the end of the tail and the stinger of the scorpion. So when you find the scorpion and you look at the tail, you look directly below where the stinger and all is, and there is Ara. Now you also see on here what I put in a light brown is something with a dashed line, and I say that this is our planetarium's southern horizon. We are in latitude, we are 31.1 degrees north of the equator, which means that there's a certain part of the sky we will never see if we stay here at 31.1 degrees. And Cindy has another chart for us we can click to of the southern, that's page 2. There you are. Here's our southern, what's called circumpolar area. Circumpolar. Break the word down. Circum comes from the word circumference. So it means around. And then polar, of course, is polar, and that's referring to our North Pole, South Pole. Here is the South Pole, right there in the very center. And since we are at 31.1 degrees north, there is 31.1 degrees of the southern sky we will never see. And there it is right there. That chart will be available for you. Eventually, you can also access the Astronomy LibGuide region there, like Cindy was talking about, and you can view that. And if you want to take and print it out, it's in PDF, and then you can use it. And if you notice, looking at this diagram, and look around over at about the 315 point on the watch scale, and you see there in the white area, there's the constellation Ara, A-R-A, and you see to the right of that, you see there is Scorpius, the tail and the stinger. But you look at Ara and you notice that there is one and there's another star that's covered over by the red dashed line. And those are the two we can't see because they're below the horizon for us. Okay, let's go back, Cindy. Let's go back to Ara and to the page. And there's what I have for you. That's what that means. There's our southern horizon. And that will change only when you go north or south toward either pole, and that will change with you. Your northern horizon and your southern horizon will change, but it's always relative of where it is where you are from the equator. So that's Ara that we have there. And like it says also, we can see the top with 14 degrees of that of latitude there. So there's two of the stars labeled that we can't see unless you decide to drive south down to the southern part of the state or even go further south, then you would see them. All right, let's go back to the calendar. And we're going to really go through the rest of this here faster so that we can finish up by 1 o'clock. On Sunday, we have some things. First of all, we have in the evening, we have what is called the solstice. That's a Latin word, and if we break that apart, S-O-L in Latin means sun. And S-T-I-C-E is a part of a word that means to stop or stand still. And you put it together, it is the time of the year when it seems that the sun has quit climbing higher in the sky every day at noon. When it's at the highest point in the sky, it seems to go up and it begins to slow down, and finally it stops. The sun stands still. And that point on the eclipse, ecliptic, and there is what we use to denote when a season begins and another one ends. So spring ends on Sunday the 20th, and summer begins on the same date. And now, also another little thing, in the evening, there you will see the planet Jupiter, and it says it's stationary in something called right ascension, starts retrograde motion from east to west. Well, all of that means is the planet is the Greek word planetes is what the was mentioned ages ago before telescopes, because there were fixed stars in the sky that people knew about. Pretty well everything you knew: sun, moon, and stars. But there was these weird stars that seemed to move around, and they would against go backward against the way the other stars were going, and wait a minute, they'd stop. And then they'd turn around and try to catch up with the stars, and then they'd stop again. And then they'd go back to going away from going against the way the stars came. Well, that is because they are wandering stars. Planetes in Greek means wandering stars. We have to remember, prior to Galileo in the 1600s, 1640 or something, when he made the first telescope to look in the sky, that everything was called stars other than sun and moon, because that's all we knew. And so they named, oh, look at there, a shooting star. Well, we know what that is. Those are little fragments of dust that come into our atmosphere, get heated up and burn, and we see them streak across the sky. We call them a shooting star. And then here's these weird wandering stars. Everything is called a star. And especially when you go into the Bible to scripture, they're listed there. And the actual planetes is mentioned one time in the New Testament book called Jude, and it's verse 13, and it's called their wandering stars. And the New Testament in Greek lists that as planetes. So anyway, let's take a look here. The next one is on the 21st, the sun. It also is traveling, and it has been in Taurus for some time, but now it's getting ready to go into the next constellation. Let's look at it. And it is called Gemini. And there it is. Now, what's interesting is look down below in the map and you see the equator down there. Well, Gemini is not an equatorial constellation, but it is, see the blue line going across the ecliptic? It is an ecliptical constellation. Now, another thing that's real interesting, look up and you'll see Gemini and then the two dark stars, numbers 14 and 17. Number 14 is Castor. Number 17 is Pollux. Those are the heads of the two twins. What did I say our latitude here at the planetarium is? 31.1 degrees north. Look over on the very left edge of the map and you see their little tick marks from plus 30 degrees, and you go up and there's a little tick mark, another one, another one, another one, and each one of those are 2 degrees. Gemini, right there, Castor, that number 14, is the brightest star that throughout the night sky goes virtually almost directly overhead, because 31.1 degrees on there is directly overhead for us in the sky. If you looked straight up in the sky, you're looking along a line left to right of 31.1 degrees. So that's what is significant about Gemini. And with that first one there called Castor, Castor, and the other one, 17, is Pollux, Pollux, we have there. Okay, let's go back to the calendar and we'll press on. Like Jupiter there on Sunday the 20th, we have also on Tuesday the 22nd, the planet Mercury does a similar thing. Mercury is very, very hard to see. And so this is what happens to it, but it's going to be hard for you to see. And there's only a certain time of the year, a couple times, when you are able to see it. It has to be the farthest away of the sun, and for the Mercury to be away from the sun, and it's either leading the sun before sunrise or it's trailing the sun after sunset, and that's the time when you would be able to see it. Okay, let's go on to Wednesday the 23rd. We had the Apogee, and now we have the Perigee. That's when in this orbit of the moon, it's when it's the closest to the sun. So again, the moon is closest now. So will it be larger or smaller than up there when we talked about the apogee? And then we go on the 24th, we have a full moon, and even though that's the time when it happens, 1:41 in the afternoon, you're not going to notice that until sunset, and then you see as the sun sets, you'll look to the east and you'll see the full moon rising. Let's go to the 25th, and we have now Draco the Dragon. And let's look at that chart there. All right, Draco the Dragon. Now, you see there's the dragon, there's his head of the dragon. He comes down, it looks like he's got two little stubby legs, if you will, and then his body, and then it keeps going on out for the tail. Well, I got you another little piece of information. Notice on there, I say that's the lower limit of the planetarium circumpolar region. Oh, okay. And if you look on that, it's 31.1 degrees away from the center down there where Polaris is almost on. There's another chart. And so Cindy, if you'll do chart number 1 of the circumpolar, there we go. There's the red dashed circle. And what that means is this is the northern circumpolar polar area. Everything inside that dashed red line is always visible every night of the year when you look to the north. Okay? Look down at the bottom of that circle and you'll see there the Big Bear, but you can see right there at the very south at the 6 o'clock position, you see the drawing for the Big Dipper. Notice that as the Big Dipper in the night sky, as time goes on, that we would lose below the northern horizon every star of the Big Dipper except the star labeled Doobie, the lip star of the pot of the Big Dipper. So anyway, gives you an idea. And here's another thing. You can see there's not a whole lot that we can see every night of the year. There's a few constellations right up at the top, up at the 12:30, 1 o'clock position is Cassiopeia the Queen. And in the planetarium, I tell and show people how you can use the Big Dipper and Cassiopeia to find Polaris, because there's a time when the Big Dipper goes down below the horizon, like it shows here. And you're going to be hard pressed to be able to use the Dipper or figure out how to find Polaris. And so Cassiopeia will be up. In other words, one or the other, the Big Dipper or Cassiopeia, will be up in the night sky throughout the year. And there's going to be times when both of them are up. But you will, once you learn where Cassiopeia is, and of course the Big Dipper, you can go out and then you'll be able to find the North Star. Okay, let's go on in our time to the calendar. Now, we had the perigee, we had the full moon, we have Draco the Dragon, our night sky tour for July in the planetarium is on the 26th. And what's our date, Cindy, for the, I believe it was, what did we say?
It will be Monday, June 28th,
Okay, the
which
20,
will be right after
yeah.
that one.
Okay, that's just because of the schedule that we have. Okay, let's
Right.
go back to the calendar.
Okay.
And that's that. On the bottom, we have, then on the 29th, we have Serpens Cauda the tail. Quickly, let's take a look at it. Notice now on it, look there in the dark area. You see the darker area, you see Ophiuchus. Ophiuchus is over there on the right-hand side. Here is his right arm, it would be holding on to, and here is the tail of the serpent. And as pointed out to you, Serpens is the only constellation divided into two separate areas there. And also, notice it is not an ecliptic constellation. See the ecliptic down there going down in the blue? But it is. Look up there in the middle, and it does straddle the equator. So it is an equatorial constellation that we have. Now, uh, the other thing I wanted to show, we have just 3 minutes. So, Cindy, if you would, if you'll bring up Draco the Dragon, the page for the dragon. And I want to point out one more thing for everybody.
I can't. Hang on.
Okay, you'll get it. While she's doing that, I want to point out, we're going to find it and I'll show it to you. There is a star there that is called Thuban, Thuban. And the significance of Thuban in Draco the Dragon is that it was the Polaris about 6,000 years ago. There it is. There you got
Yeah,
it. Very
it
good.
was being hidden by the
Oh,
panel here, and I couldn't grab it. So we're
okay.
good.
Okay, everybody, look at the map of the dragon. Look for star number 4. Number 4 is Thuban. That was it was Polaris back in about almost 4,000 BC when the Egyptians were building the pyramids. What the astronomers have found out over the years scientifically is the Earth behaves like a spinning top. If you've ever played with or used to, or you watch a child play with a spinning top, what happens to it when it begins to slow down? It begins to wobble. That's a technical term, wobble. But anyway, Earth wobbles, and we call that, the astronomers call that precession, Precession. All that means is Earth wobbles. How long is one full wobble? Well, it takes a long time, 26,000 years. So if Thuban was our Polaris back in just under 4,000 BC to right now, almost 6,000 years, we have only in 6,000 years gone 23% of the total path of the precession going completely around. Well, we're almost out of time, so let's go back. We can just get out of the calendar, everything, and whatever you want to wrap up with, Cindy, fill them in.
All righty. Well, first of all, we want to remind you that the Mabon Science Theater is now open for in-person Warren. He's going to be continuing to do the virtual events with us. We have another one at the end of this month. If you will put this on your calendar, it's going to be here at CTC's Facebook on Monday, June 28th. That will be after his in-person one. Then we're going to move his virtual night sky events to the CTC Libraries Facebook. And so we have included here the location of the August constellations and the September constellations. And we're trying to get it in line with the in-person ones so that after Warren has talked about the event, then you can go to the dome, the planetarium, and actually watch it on the big dome. You can find all the information of the night skies. We put this in our comments. It's our library events calendar. And we've got something else fun that Warren has created for you guys. He has been making, on top of our constellation maps, our nighttime skies, astronomy books, databases, films, internet resources. He has been adding fun activities to this LibGuide. So therefore, he creates these crypto puzzles, and we did one for the month of May. If you want to send us your answers, then we can see if you've got them correctly. And we posted last month's answer. We've got June all ready to go for you to answer. The same with the drop quote boxes. Here's how to play them. This was May. You can send us your answer, and there's the answer. And we now have June. So Warren puts a lot of effort into these puzzles, and it would be a lot of fun to see. Oh, and they are astronomy related.
Yeah.
So
And
these,
also, Cindy,
mhm.
I will give to you here in a day or so, a third puzzle for them. Imagine there's people that are familiar with word search when you do word search and on that, and some have done the logic puzzles of Sudoku. Well, I've put the two of them together, and you're going to have a word search Sudoku puzzle, and it will be astronomy related.
There you go. So this our astronomy lib guide has any information you need. It directly connects to the shows. Um, it's taking a while to, there we go, to the shows that we have. Um, we also have information like when it's open, when the night sky tours are going to be, and some films, your fun activities, citation resources. It has it all. So if you are an astronomy buff and if you are a fan of Warren Hart, this whole lib guide is Warren Hart's heart and soul. So please remember to join us again at the end of this month for our next constellation tour. So Lee, did we have any questions or any answers?
There were no questions or answers.
All right. So and I sort of answered some of your questions when I was on mute.
You sure did. I could read your lips, and
I
you
just
were
didn't
correct.
I didn't want to unmute just in case I had the wrong answer.
No, no.
I don't have any helpers. All right. Well, let me stop sharing. So, Warren, thank you so much again for taking the time to do another night sky tour with us. And we will go ahead and upload this tour as well on the LibGuide. So,
Okay. Thank
and thank
you.
you for taking the time. I learned something new every single time you do one of these. So, this is my astronomy class. All right. Well, guys, listen, thank you. And check out that library events page because we have a contest, two contests going on right now, a yo-yo contest and a talent contest on our library events page. So look back at it in that link and send in your videos so that we can go ahead and find a winner. Also, in the middle, toward the end of the month, in the June 21st, 22nd, 30, 23rd, or 24th, one of those days, it's on the events calendar. We have Martial Arts Week. So we have three different studios in our Colleen area, and they are going to be demonstrating Kung Fu, Brazilian Jiu Jitsu, and Taekwondo. So that'll be a lot of fun as well. And then, of course, we'll have Warren and another night sky tour at the end of this month. Thank you guys for joining us, and you guys have an awesome day today. And look, it doesn't look like it's raining today. So hurry up, everybody go out and mow your lawns.
Yeah.
All right. Thank you, and thank you, Warren. Lee, you
You're
can take
welcome.
us out.